Hello friends, welcome to follow up. Let's have a look at problem 24, swap nodes in pairs. This is a daily challenge problem, and this problem is also very classic now. So in this video, we're going to explain a solution based on doing a simple linear traversal. Here in this problem, we are given a linked list, so we are required to swap every two adjacent nodes and return its height. So here we must solve the problem without modifying the values in the list's nodes. In other words, only nodes themselves may be changed. So here we have three examples. Example 2 and example 3 are special cases because example 2 represents an empty list, so we just return the height itself. And in example 3, so it contains only one node. Therefore, we just return this height itself. So the constraints for this problem are the following. First, the number of nodes in the list is in the range given by the closed interval 0 and 100. So the node values are basically in the range 0 to 102. However, this does not mean that the values of the nodes are unique, right? So with that said, we are ready to do the coding part, I guess. So basically, let me make some annotation. Here is the method or approach, so we just use a linear traversal. So basically, I want to use two variables. It's like a two-pointer method, but it's not in a rigorous sense. So you can think of this this way, but essentially it's just a for loop. Here also I would like to demonstrate that we want to use a dummy node trick, right? So here during the coding part, first I'm going to make a dummy node, right? So I'm going to instantiate a list node object. So let's take a value. So here the value is in between 0 and 100. Let's take a value, say -1, right? Then we connect the dummy with respect to the head, and then we can conveniently do the traversal. So here for the swapping purpose, I'm going to introduce a variable. This is called dummy, and then basically it's a while loop. So in the while loop, we need to specify condition for stop. Here we are going to set height and height next. In other words, we have at least two nodes so that we can do the swap. So then, if this is the case, so we are going to do first node and the second node. So going to be height and height next. So if you want to use example 1 to help understand, you can think of first node to be the node with value 1, and the second node to be the node with value 2. So here let me write second node, just for using suggestive names. So then what we are going to do? So we are going, after we swap 1, 2, then the dummy or the previous will first connect to 2, right? So in other words, the dummy or the previous next will be second node. And then after we swap, the first node will point to 3, right? So in other words, first node next will be the second node next. This can be empty, so if you know if the length of the original list is just 2. Now we need to use 1 as the follower for 2, right? In other words, second node next will be first node. So this way we finish the swap. Next we want to update the variables. First previous and also head. So previous will be the first node now, right? So after you swap, you're going to have 1. So this is the previous, and the height will be 4, right? So in other words, first node next. So we write first node next. This is always correct. So after this while loop, basically we will finish the swapping. So this way, we just need to use this this one-way traversal. So this is while loop basically just a traverse of the list from beginning to the end. Then we just need to return the head. So this is a solution format to this problem. So before we make any comments, let's first do a check. Here is wrong. Let me examine. So we have dummy, right? Dummy next equals head. Then we have previous. Then we have head and head next. So the first node will be the head, and the second node will be head next. Then we are going to set previous next to be the second node, and the first node next will be second node next, right? And then second node next will be first node. Then we do previous and head will be first node, and the first node next. So then what we want to do is actually our problem is in the return. So actually we need to return the dummy next, because this can be changed, right? So this is exactly the reason we introduced this dummy variable. So now let's check again. Yeah, it's now it's right? So now let's look at the generic case. Yeah, it passes all the cases. So with that said, I guess basically that's about it for this classic problem I would say. Actually, this problem can be solved by a number of other variants of this idea. So you are encouraged to have a try. With that said, that's it for this video. Thank you.